All right, welcome guys. We're going to go ahead and get started with 5.5 today. We're going to be talking about bases other than e. So far in 5.4 and prior to that, we've been dealing with natural log, which is a base of e. We've been dealing with e to the x, which is a base of e. Well, what about all those things that don't have a base of e? We have all kinds of numbers, 2 to the x, 3 to the x. We have log base 7 of x, all those different things. Well, we're going to actually be looking at with what the derivatives look like for those. And so starting out, remember we have things like y equals log base a of x, or y equals a to the x. These are bases of a being some kind of constant, some number. Okay, we say this is a logarithm with base a. Okay, and these bases change how we evaluate our logarithms or our exponential functions. Okay, rather than using the e. Well, all of our properties still apply to logarithms. Okay, we have those properties. These are inverses of each other. So they have those similar functions to the inverse properties, or properties of inverse functions that we talked about with natural log and e to the x. So the first one, if we have y equals a to the x, right? This is if and only if x equals log base a of y. This is how you convert back and forth between exponential and logarithmic form. All right, this is how you rewrite the two. The big one that we use all the time is that if you have a to the log base a of x, they cancel out just like e and natural log did, and you end up with x. And the flip side of that, if you have log base a of a to the x, they cancel out to give you x as well, just like if you had natural log of e to the x, or this one, if you had e to the natural log of x, these things canceled out with that. Okay, well, let's practice our solving. Just like we did with our exponentials, we need to be able to solve these occasionally. So if we solve for x, if I have 3 to the x equals 1 over 81, or a second one over here, log base 2 of x equals -4. Now, both of these actually can be solved without having to do any crazy properties or anything. We can actually rewrite them into certain powers. But here's the thing. With this, the easiest way to tackle these type of problems, especially this one, is to rewrite them in the same basis. Now, 81 can actually be rewritten as 3 to the 4th. Well, if it's down there in the denominator, we can actually rewrite it as 3 to the -4th. And now if you have 3 to the x equals 3 to the -4, then x has to equal -4. All right, so when they are able to be done with the same base, that's the easiest way to do. Another way to do this is using those inverse properties. We do it over here on the side. We have 3 to the x equals 1 over 81. Well, if you know your powers, this helps out a lot. But if you did a log base 3 to both sides, all right, that cancels that out, and x is going to equal log base 3 of 1 over 81. Now, to most of you, that isn't going to mean a whole lot of things. But again, if we can rewrite this, 1 over 81 is 3 to the -4th. We see that log base 3 of 3 cancels out, giving us the -4. Now on this one over here, easiest way to tackle this one, all right, just like with natural log, to get rid of natural log, we eat it. Well here, whatever the base is, in this case the base is 2 it. All right, when you 2 it, 2 and the natural log of 2 cancel out, giving you x equals 2 to the negative 4th, which would just be 1 over 2 to the 4th, which is 16. Okay, so that's how we solve and get rid of exponentials and logarithms with different bases. Now, let's talk about the derivatives associated with these. And most of the times, what we're really going to be working on with exponentials and logarithms with different bases is just the derivatives and integrals. So differentiation. We have a couple rules. So here, let A be a positive real number where A does not equal 1 and let U be a differentiable function of x. We're going to do a little bit of chain rule, just like with natural log of u. We did u prime over u with the derivative. Well, we're going to do something similar with our logs and exponentials here. So, basic rule first. If we take the derivative of a to the x, okay, a being a constant, a real number, as we said, all right, the derivative of this is going to be natural log of a times a to the x. Okay, natural log of a times a to the x. So we're still keeping that a to the x in there, but we're multiplying this by natural log of a. Now, if this is a to the u, so again, this is where we have chain rule involved. All right, so this would just represent our chain rule. So u is going to be some differentiable function. We're still going to have natural log of a. We're still going to have a to the u, but now remember that d stuff, we got to multiply by u prime. Okay, so it's just one extra step involved with that piece. All right. Third, we're going to throw in our log base a now. So derivative, if you have the log base a of just x, all right, this is where we just have x in there. All right, the derivative would be 1 over natural log of a times x. All right, 1 over natural log of a times x. And let's go ahead and add our chain rule. Again, if there is a u in there, if there is some kind of differentiable function, all right, if you have some stuff inside that logarithm, okay, let's treat it as a u again. So this time we have log base a of u, right? Things are going to be the same. We're still going to have 1 over natural log of a, but instead of x, we're going to have u. But then again, d stuff, we got to multiply by the derivative of u. All right, so we do get u prime on the outside, and that's really going to go in the numerator here. So if you wanted to, you could do u prime over natural log of a times u. Okay, and so these are our 4 new derivatives, and really 2 new derivatives. Okay, you can really just kind of think in terms of the chain rule one. That's the one we deal with the most often. Okay, so let's do some derivatives here. Let's do some practice problems. Okay, so find the derivatives. Let's do our first one here. A y equals 2 to the x. B, let's do y equals 3 to the 5x. And then we're going to do C base 7 of cosine of x. Let's add that trig in there for a little fun there. Okay. All right, starting off with our first one. So this is just basic a to the x, okay? There's the exponent is just x. So when we take our derivative for this, all we're going to do is natural log of a in this case is 2, times 2 to the x. Okay, that's it. Okay, there's no stuff in there. Even if we wanted to do u prime, the derivative of x is 1, so we don't really need that. All right, now on the second one we're going to do a little extra work for. Okay, y prime on this one, same idea. Our a is 3, so we're going to do natural log of 3 times, okay, we're going to do 3 to the 5x, so 3 to the 5x, but then times, now we got to do the d stuff, okay? D stuff, what is the derivative of 5x? It is 5. Okay, and really the 5 and the natural log of 3 can get put together. 5 natural log of 3 times 3 to the 5x. Okay, and so that would be our final derivative of b here. Now let's take a look at c, the fun one with a little bit of trig. Okay, so here we're dealing with log base 7, okay, of cosine. And so remember, this is going to be our u here. So derivative 1 over natural log of a in this case is 7. U is cosine. And then, what's the derivative of cosine? We got to do that u prime. Derivative of cosine is negative sine of x. And so we can put this together as negative sine of x over natural log of 7 times cosine of x. Well, they may simplify this a little bit, and we can see negative sine over cosine actually gives us negative tangent of x over natural log of 7. Okay, so that's an acceptable way that we could see this simplified down, let's say a multiple choice or something like that. All right, well, that's pretty much the derivatives. It's just plug into those formulas and simplify where needed. Well, let's talk about integration. Now, with integration, there's really not much to it. In fact, we only have one new integral to learn for this. All right, that is it. We only have one new integral, and it's actually the opposite of our exponential, pretty much. All right, so we're going to do the integral of a to the x dx, and that new integral is going to be 1 over natural log of a times a to the x plus c. So whereas the derivative is natural log of a times a to the x, integration is 1 over natural log of a times a to the x. All right, so that's really the only one. We don't have an antiderivative for log base a. Okay, we do end up using u substitution once in a while on this. So let's take a look at 2 examples here. So our first one, let's do 2 to the x dx. All right, nice and simple. So we're starting off here, and really we're just going to use that formula. A in this case is 2. So our antiderivative is just going to be 1 over natural log of 2 times 2 to the x plus c. How nice is that, right? And we can always write that as 2 to the x over natural log of 2 plus c. A lot of times they are going to write it as a fraction like that. Okay, so they'll just put that in the numerator. All right, well, let's add a little u substitution to this. Let's spice it up a little bit. Our second one is going to be integral of x 5 2 to the x squared dx. So obviously we have some extra stuff going on here. And so whenever we have that extra stuff, we got to do a u substitution. So let's start off with u. U is going to be what's in the exponent here. So 2x squared. And so let's go ahead and take the derivative. Du will equal 4x dx. And if we take a look at our problem, hey, I got the x and the dx. What I'm missing is the 4. So let's go ahead and add 4 out front here. But I can't just add 4. What am I going to put out front of that? All right, I need to put a 1/4 to balance it out. So now let's go ahead and do all of our substituting. 1/4 integral. 4x dx becomes du. And we have 5 to the u. Well, now we can go ahead and integrate that using our formula we just had. which is 1/4 is going to stay there. That's our constant multiple. All right, our formula is 1 over natural log of a, so natural log of 5 times a to the x, or 5 to the u in this case, plus c. Well, remember, u means unfinished, so let's go ahead and put our u back in, and let's put all this together. The 1/4 times 1 over natural log of 5 can just be 1 over 4 natural log of 5, and times 5 to the u was 2x squared plus c. And again, just like before, we can write it as a fraction, 5 to the 2x squared over 4 natural log of 5 plus c. Okay, and that's really all derivatives and integrals for bases other than e. All right, we don't really have to get too complicated with this. This isn't a super large part of the AP exam. We see a couple questions here and there. But the biggest thing is we need to learn our new derivatives and our one new integral, add that into our toolbox of derivatives and integrals that we need to have at disposal to use when they pop up. Okay, tonight's homework is actually just practicing these derivatives and integrals. Okay, there's not much more other than that. All right, so get those down, practice them, and then in our next class, we'll go ahead and go over any questions that you may have to make sure we're good. All right, have a good one.